This is the Math 227 Statistics. Today we will learn Chapter 1, the nature of probability and statistics. Chapter 1, the nature of probability and statistics. First section, the topic is descriptive and inferential statistics. Definition of statistics. What is statistics? Statistics is the science of conducting studies to collect, organize, summarize, analyze, and draw conclusions from data. And there are, what is a variable? A variable is a characteristic or attribute that can assume different values. What is a population? A population consists of all subjects that are being studied. All subjects that are being studied. What is a sample? A sample is a group of subjects selected from a population. So sample is the subset of population. It's a partial of population. Example, population and the sample. Population, if we assume Los Angeles Southwest College students, assumes the population, then the Math 227 students is the sample, is a part of Southwest students. Second example, like United States. Sample is California, because California is a part of United States. So it's the United States is population, California is a sample. If a third example, if a population is a man in United States, then men who live in California is a sample. If Math 227 students is a population, then females who are taking Math 227 is a sample, because female who are taking Math 227 is a part of the Math 227 students. Next, there are two areas of statistics. First, descriptive statistics consists of the collection, organization, summarization, and the presentation of data. Second kind, we call inferential statistics, consists of generalizing from samples to populations, performing estimations and hypothesis tests, determining relationship among variables, and making prediction. That's the first section. Second section, variables and the types of data. There are two kinds of variables. qualitative variable and the quantitative variable. Qualitative variables are variables that have distinct categories according to some characteristic or attribute. Quantitative variables are variables that can be counted or measured. Example, qualitative variables like gender, male, female, like shape, like a square, triangle, rectangle, color, example, like a yellow, red, brown, blue, or geographic locations like Alabama, Georgia, New Jersey, California. Those are qualitative variables. Quantitative variables like age, like 5 years old, 7 years old, like height, like 6 feet, 7 feet, like weight, like 150 pounds or 70 pounds. Temperature, like 75 degrees in Fahrenheit. So quantitative mostly are the using number to represent. Qualitative using word to represent. Quantitative variables can be classified into two groups. Quantitative number using number, or variable using number, like discrete variables assume values, numbers that can be counted. Continuous variables can assume an infinite number of values between any two specific values, means between two numbers still have infinite numbers as continuous variable. And they often include fractions or decimals. Discrete variable like number 1, 2, 3, 4, 5, 6, and etc. Those numbers called counting number can be counted. And between 1 and 2, or 2 and 3, between two numbers, there's no more integer, no more such kind of counting number. Continuous variable like number in fraction or decimals, between two decimal or two fractions still have a decimal or fraction, still have an infinite number between two numbers. That is a continuous variable, like a fraction or decimal. This discrete number like integer, whole number, natural number, and the continuous variable like a real number. So variable, there's a qualitative and the quantitative, two kind of variables. Qualitative normally represented by word, and the quantitative variables normally represented by number, like a discrete number of pages in a book, or amount of money. Amount of money is a discrete number. Continuous number like speed, weight, height, temperature are continuous variable. So Why amount of money is a discrete variable? Because the smallest value that money can assume is in cents. In cents. There's no values between $1.01 and $1.02. And we stop at 2 decimal digits at cents. The smallest value we assume is cents. So between 101 cents and 102 cents, 101 cents and 102 cents, there's no more numbers, no more cents. So amount is discrete variable. Next example. Classify each variable as discrete or continuous. The highest wind speed of a hurricane. Speed is continuous. Here, speed is a continuous number. Here is answer. The weight of baggage on an airplane. The weight is a continuous variable. The number of pages in a statistics book is discrete because number 1, 2, 3, 4, that's pages number. The amount of money a person spends per year for online purchase, that's discrete. Amount of money is discrete variable. Next, when measuring continuous data, rounding occurs. Therefore, the boundary of a number is defined as a class in which a data value would be placed before the data value was rounded. For example, the boundary of a height of 73 inches would be given as 72.5 because 72.5 you round in will be 73 up to 73.5 but not including 73.5 because any number more than 72.5 like 72.6 72.7 until 73.4. Then you round up 6, 7, 8, round up, get 73. Like 73.4 or 73.3 is less than 5. You truncate, you still get 73. So after rounding, the number is between the boundary notation 72.5 to 73.5 implies all the values from 72.5 up to 73.5, but not including the upper bound 73.5, because 73.5 rounding is 74. So all the numbers from 72.5 to 73.5, but not including 73.5, all such number after rounding, you got 73. So we call the boundary of 73 would be given from 72.5 to 73.5, but not including 73.5. For example, like 74, the boundary will be 73.5, more than 73.5, greater than or equal 73.5, the number, but less than 74.5. Those numbers, after rounding, you got 74 between the two, but not including 74.5. all the number between 73.5 to 74.5. You rounding, you got 74. So this we call boundary. Like number 1, a boundary is between 0.5 to 1.5, not including 1.5. Like 20, the boundary from 19.5 to 20.5. Would be placed before the data value was rounded. Next, 4 level of measurement. First one is nominal. The nominal level of measurement classify data into mutually exclusive, non-overlapping categories, in which no order or ranking can be imposed on the data. Category, which is name. N, nominal, name. It's a nominal category, name. Nominal, N, name, it's name. Ordinal is level measurements classify data into category, also in name, in character, in name. That can be ranked. Ranked means ordinal, means have order. Nominal is a name. Ordinal is the name with order. Like nominal, for example, like name like Alabama, California. There's no order. Like New York. Those are just nominal, a name. Ordinal have order. For example, like letter grade, A, B, C, D. Those are categories in letter, but have order. You can compare it. Like, for example, like a pizza size. Pizza size has a small size. Small, medium, and large. Small, medium, and large have order, have ranked order, but in name, in character, in letter. So this all ordinal, it's order, nominal, and name. Interval is number. The interval level of measure ranks data and the precise difference between units of measure to exist. However, there is no meaning of zeros. It's interval. Interval like a temperature. Your temperature can be above 0 or below 0. You have a negative temperature, positive temperature. So there's no starting point. There's no meaningful zeros. You can below zeros. That's interval. Interval is represented by number, but there's no beginning zeros. Next, ratio. Ratio is a number, the ratio, but have true zeros, beginning zeros. The ratio level of measurement possesses all the characteristics of interval measurement. And there exists a true zero. So following are examples. Nominal, like gender, is nominal, is name, like male, female. Like color is nominal. Like yellow, blue, those. Nationality, like countries, like United States, British, Mexico, Canada, Those are nationalities. Major field, for example, in mathematics, major in mathematics, major in chemistry, major in science, major in music, major in arts, major in English. Those are, there's no order. You can compare it. It's with a name. That's a nominal measurement, level measurement. Ordinal has is also represented by word or letter, like grade, A, B, C, D, F, and by letter, but have order. You can compare it. Rating, like poor, good, excellent, is also represented by word or letter, but have order of it. We call ordinal. Like ranking of tennis players, like first rank, first position, or second position, third position. You can say golden, gold, silver, and brown, right? Gold, silver, and brown. And like pizza size, you can have a small or medium and large. And those are using a word or using letters. It's not represented by the number. And those we call ordinal, have order. Then interval is in numbers, but there's no starting zero. Like SAT score. SAT score is an interval. There's no starting zeros. Like IQ also. There's no starting zero. Like temperature you can below zero, like negative temperatures. Another one, ratio. Ratio have a starting zero. Like the height is started at zero. You cannot have a negative heights. So start at zero and positive number. Weight also. Weight, you don't have negative weight. There's starting zeros. Like time, you don't have a negative time. You start at 0 seconds, 0 hours. Salary also, you don't have zero. You can have a zero salary. You don't have a negative salary. Like age, you don't have a negative age. So those have a starting zeros. We call ratio. The following examples. What level of measurement would be used to measure each variable? A. The ages of patients in a local hospital. That is a ratio because age has starting at 0 years old. The ratings of movie released this month. Rating of the movie is rated by characters, but they has order of it, so it's ordinal. And the colors of athletic shirts sold by Oak Park Health Club, the color is nominal. There's no order of it. Yellow, blue, there's no rank of it, but represented by word. So it's nominal, is the name of it. Temperature of hot tubs in a local health clubs. Temperature can be below 0, have a negative temperature. So there's no starting zeros. Temperature we call interval. So interval and the ratio, both represented by number, but ratio have a starting 0. Interval, no starting 0. Order and the nominal represented by word or character, letters. But nominal, like a name, there's no rank, no order. Ordinal, like is with the name, but have order, have a meaning of order, rank. Section 3. Data collection and the sampling techniques. telephone surveys and online surveys are common methods to collect data. However, these methods are not ideal due to bias. So, to minimize sample bias, statisticians use 4 basic methods of sampling. See the last page for the diagram. First one we call a random sample. A random sample is a sample in which all members of the population have an equal chance of being selected. Unbiased sample. Unbiased sample. For example, this is a first one, random sampling. This. Each member of the population have an equal chance of being selected. Computers are often used to generate random telephone numbers like this. It's a random sampling. Second one, systematic sample, is a sample obtained by selecting every case member of the population where K is a counting number. Like every fifth, K like K equal 5, is every fifth member. Like K equal 10, then every 10 member be selected in a sample as a sample. For example, like this. Systematic sampling. Select some starting point and then select every case, such as every 50th element in the population. Like this, 1, 2, 3, every third, then 1, 2, 3, then 1, 2, 3, every third as example. Next one, stratified. Stratified sample is a sample obtained by dividing the population into subgroups or strata according to some characteristic relevant to the study. The subjects are selected randomly from each subgroup. The subjects are selected randomly from each subgroup. For example, like this. Stratified sampling. Subdivide the population into at least 2 different subgroups, or called strata, like this. 2 different women, and men, so that subjects within the same subgroup share the same characteristics, such as gender or age bracket. Then draw a sample from each subgroup. Like this, from women, you draw those 3%, and from men, you draw those 3 men. From each strata, from each subgroup, you randomly choose some of them as form a sample. Then next, cluster. A cluster sample is obtained by dividing the population into sections or clusters, and then selecting one or more clusters and using all the members in the clusters as the sample. So clusters like this, the United States, divide the population into sections or clusters like this, divided. Then you randomly select some of those clusters, like here, select 3 clusters, entire from those select. Choose all of members from those select clusters, like this, select those 3 clusters, entire clusters. That's what we call cluster sampling. And what's the difference between stratified sampling and cluster sampling? Stratified sampling is divide the population into subjects, subgroups. From every subgroup, select sample of it. Each subgroup, like this example, the population of the people, human being, divided into 2 subgroups. From each subgroup, select 3 of it. All the subgroups, you select the sample. But for clusters, you divide population into subgroups, but select entire some of the subgroups, entire subgroups. Like this, divided into, I guess here is 32 subgroups. Select 3 subgroups, entire subgroups, and that's its clusters. Next one. Experiment. Experimental design. In an observational study, the researcher merely observational is observe what is happening or what has happened in the past and try to draw conclusions based on this observation. Happened in the past, observed the past. And experimental study, the researcher manipulates one of the variable and tries to determine how the manipulation influence other variables. What that means? In a true experimental study, subjects should be assigned to groups randomly, and the treatment in experimental line have a treatments should be assigned to group randomly. When random assignment to groups is not possible, intact groups are often used. When intact groups are used, the study is called quasi-experimental study. So, observation study is just observe the data and draw conclusion. Experimental study is you treat, for example, like give treatment, medicines or treatments, then draw the conclusions. So the independent variables in an experimental study, it's the variable being manipulated by the researchers, called independent variables. The independent variables is also called explanatory variable. Explanatory variables. The outcome. Independent variable is the input. Independent variable, input. Then output, result variable, resultant variable, result variable is called dependent variable. It depend on the independent variable. The result is depend on the input. So output is dependent variable, or called outcome variable. Outcome variable. Consider the following study on sit-ups. A study at Virginia Polytechnic Institute divided female undergraduate students into two groups and had students perform as many sit-ups as possible in 90 seconds. The first group was told to do your best. The instructions is do your best. Then, while the second group was told to increasing the number of sit-ups each day by 10%. Instruction to the second group is increasing the number of sit-ups each day by 10%. So after 4 days, the first group averaged 43 sit-ups, while the second group averaged 56 sit-ups, more than the first group. Why? So the conclusion was that athletes who were given specific goals performed better than those who were not given specific goals. So if it just tell you do your best, the conclusion is less. Improvement is less than when asked to increasing the number of sit-ups each day by 10%. So what is the independent variable? Independent variable is the type of instructions. Do your best is an instruction, and the other one is increasing the number of sit-ups. There's two types of instructions. Those are independent variable. The conclusion, outcome variable. What is a dependent variable? Dependent variable is the number of sit-ups. Different input, different independent variable, then different type of instructions, and you got different outcomes. Confounding variable. Confounding variable influences the dependent variable, the outcomes. Confounding variable influence the dependent variable. Dependent variable is also called outcome variable, output, but cannot be separated from the independent variable. Cannot be separated from the independent variable's input variable, also called explanatory variable. That's next one. Uses and misuses of statistics. There's 1, 2, 3, 4, 5. Suspect samples. Suspect samples is the sample size large enough, or how was the sample selected, or is the sample representative of the population? Those questions for the sample. Or ambiguous averages. What particular measure of average was used and why? Or detached statistics. 1/3 fewer calories. And then what? Or misleading graphs like this example. This graph, the two graphs. The question is, are the scales for the x-axis, this one is x-axis, and the y-axis appropriate for the data? Appropriate for the data. That's a misleading graph like this one. For example, like test 1, the score is 92. Test 2, score also 92. Test 3, score also 92. So like this. A graph is a line, horizontal line. But if you draw the graph like this is test 1, test 2, test 3 for horizontal is the same. And vertical score, if I put like this one, I put 92 here, here's 50, here's 100. Then 92 is less than 100 is here. But I do put this like this, and here zapped means cannot show up. And I put 92 here, and 92.1 here, 92.2 here. Then your test score, first test, you got 92. A person, second test got 92.1. The third test get 92.2. And then you connect. And look like this graph, this person's test, 92 from 92 to 92.1 to 92.2. And if you draw like this, like this, is better, improved, have an improvement, better than this, because this all are 92 horizontal. This one look like have much improved. But question is, was there a significant improvement in the test scores? Answer is no, because from 92 to 92.1 to 92.2, only little. There's not significant improvement in the test score. So this graph is misleading. Misleading graphs. You just look at the graph, you look like probably that this person's test have more improvement. This doesn't improve, but not significant improvement, very little. So are the scales for the x-axis and y-axis appropriate for the data? So you cannot compare the two graphs to draw the conclusion. This is a misleading graphs. The next, 40 survey questions. Do you feel that the North Huntington School District should build a new football stadium? You ask like this, or you ask, do you favor increasing school taxes so that the North Huntington School District can build a new football stadium? The two is, here's do you feel, here's do you favor increasing school taxes. And the two if the two questions put into the survey sometimes were misleading the people.